Hi everybody, today we're going to be focusing on an ellipse, which is the third conic of this section. I've got a picture here just so you could see the difference between the circle and the ellipse in terms of our cones. Remember when we first started talking about conics, we said that a conic was formed by taking a slice of a cone. So notice to go and get a circle, we go straight horizontally through the cone. To get an ellipse, we go at a diagonal. And so they're going to be very similar in characteristics and their equations. There's just going to be some slight differences. So an ellipse is like an oval. That's going to be the easiest way to remember it. And the formal definition says that an ellipse is the set of all points where the sum of the distance from two fixed points is constant. And I know that doesn't really mean much now, but we'll kind of explain here in a second. But what's important to know is that an ellipse has a lot of really good application. You could see ellipse shapes in space. So if you think about planets orbiting, they have an elliptical orbit. Or if you've ever heard of whispering galleries, where you can stand at one side of the room and whisper to your friend on the other side and you can hear them. This concept comes from the ellipse shape of the room or the ceiling, and that allows you to hear things from a distance away. And then if you also have used an elliptical at the gym or something like that, the movement of your feet has an elliptical movement to it. Hence the reason they call it an elliptical. All right, so what we're going to do is go ahead and start off with the key characteristics of an ellipse and label some things on a basic graph, and then we're going to talk about the equations and how to graph them. So here's a picture of an ellipse. An ellipse can actually go two different directions. An ellipse can be horizontal like this, or it could also be vertical, so it might look something like this. And there are some key characteristics of an ellipse. The first one is your center, so that's going to be right in the middle. It won't always be at 0, 0, but it can be. And then the second part we're going to talk about are the vertices. So the vertice, or the vertex, is going to be 2 points on the ends of your ellipse. And the vertex, or the vertices, we're going to label with V's. And those are always going to be on the longer side. So the vertex is going to be on the longer side. And we call that longer side the major axis. Okay? The co-vertices, so I'll put those here in blue, those are the other sides of the ellipse. And I'm going to label those CV, so those are the co-vertices. And those are going to be on the shorter side. All right, so they have two of them, so two vertices, two co-vertices, and then the center. And then the points that are probably the most important of an ellipse are the foci. So the foci are inside the circle. These are the points where you would stand if you were in a whispering gallery so that you could hear one person to the other. So I'm going to label those with F's. Notice that in a parabola we had a focus. Same thing, except in an ellipse we have two of them. So those are the foci. There. Okay, and those are going to be inside the ellipse. And these are also always on the major axis. So I'm going to write that down. So always on the major axis. Co-vertices are always on what we call the minor axis. Okay, and if I can write that below, I'll do this here in green. So the major axis is the long side, and the minor axis is the short side. Okay? And if you have any questions about that, make sure you let me know. The same things apply when it goes up and down instead of left to right. So here would be our vertices up and down because that's the longer side. The co-vertices would be the left and right, so co-vertice here and here. And then obviously your center would be right in the middle of the two. And then your foci would be along the same lines as the vertex. So notice the vertices and the foci and the center are always going to be in one line, so that's really important. Let's go ahead and start off with the equations now that we've gotten the basic pictures drawn. There are two equations, obviously, because these can go two different directions. So the first equation is going to be where we have x squared over a squared plus y squared over b squared equals 1. in an equation, a standard form equation of an ellipse will always be equal to 1. Okay, and if your equation is in this order with x squared plus y squared, then that means the orientation is horizontal. So the long side goes left to right. Your foci, which we'll talk more about here in a minute, are going to be at the points c, 0 and negative c, 0. And we'll talk about how to find those here in a minute. The length of the major axis, so the long side, is going to be 2 times a, okay, and the length of the minor, so the up and down, would be 2 times b. And notice we have an a and a b in our equation, so we're going to practice how to use those here soon. The other equation is just the reverse, so this time we'd be y squared over a squared plus x squared over b squared equals 1. So the only difference between the equations is which letter came first. So x squared came first here, y squared first came here, so that means our orientation is going to be up and down. Okay. So our foci are going to switch, so it'd be 0c or 0 negative c, because now they have to go up and down. Our major axis will still be 2 times whatever a is, and then the minor would be 2 times whatever b is in this case. So when I'm asking you to write the equation of a line, the first thing that you always want to do is figure out the direction or the orientation of the graph, and then you also want to figure out your a, b, and c value. That's going to be really important in writing your equation. So first things first, I'm going to draw a quick little sketch just to get an idea of the direction of the graph. My vertices, which remember are the long side, are at -4, 0, and at +4, 0. So this graph, because the vertices go left to right, it's going to be a horizontal ellipse, which means the equation I need is this one here. So remember, you want to have those handy so you can fill in what you know. So then all I have to figure out is what's a squared and what's b squared. Well, remember, a is the distance from the center to the vertex. Okay. B is from the center to the co-vertex, and then C is the distance from the center to the focus, to one focus. All right, so I can go ahead here and look at what I've got. So I know from the center, which is 0, 0, to the vertex is going to be 4. So that's going to be 4. The only other thing they gave us were the foci, and those are at 2, 0 and -2, 0. So to go from the center to one of those foci would be a length of 2, and we don't know what b is, but notice in our equation all we need is a squared and b squared. This is where that formula from the last slide is going to be extremely important. So I'm going to go ahead and plug into my formula, c squared equals a squared minus b squared, and plug in what I know and then solve for b squared. So I know that c is 2, so I'm going to get 2 squared equals 4 squared minus b squared. If I start to solve, I get that -12 is equal to -b squared, so I did a few steps here. And then I divide both sides by -1, and then I get b squared is equal to 12. And this is exactly what I want here. So when I write my equation, I could have y squared over 12, because that is b squared. And then on the other side, we knew that my a value was 4, so we're going to have x squared over 4 squared, which is 16. And then we could just set that equal to 1. And there's our final equation. So we have a center at 0, 0. The points here on the bottom represent the vertex and the co-vertex, and it's always equal to 1. And we're done. All right, so I want you guys to try this one here right below. I tell you the foci are at 7 or 0, 7 and 0, -7, and the vertices are at 0, 9 and 0, -9. So remember, you need to first figure out the center and the orientation or the direction. That's going to dictate which equation you use. And then you need to figure out what A, B, and C are and fill into your equation. And if you have any questions, please make sure you ask me in class and I could go through this example with you.